Welcome to our 10th lecture in 18 IT 475, mobile application development. We are going to look at three major concepts this week. One of them is exceptions and exception handling. Another one is advanced intents and being able to invoke an activity that will return to the calling activity. And finally, we'll look at menus. These are all related because they deal with how our activity interacts with other layers in the application and other activities in the application. So you might recall earlier on this quarter, I asked who really understands interfaces and who doesn't understand interfaces. I find when we get to the 400 level and people are ready to graduate, there are two concepts that really have not sunk in. One is how to properly use interfaces. The other is how to properly use exceptions. Exceptions feel like a necessary evil if you don't know what they are. But if you know what they are, they're actually quite handy. Let's think about it this way. Remember that we have three layers of our application. We have the visual layer, which interacts with the activity and the layout, and then we'll have the service layer, and then we'll have the persistence layer. Now, the user interface layer, it's going to be hard to avoid using Android-specific libraries there. But the other layers, the persistence layer and the service layer, as much as possible, we want to keep these application independent. We want to keep them operating system independent, rather. And that is, they should not have any Android-specific libraries imported into them. That way we can easily reuse them on other platforms without any hard-coded dependency. One important lesson here is that if that's the case, then we should not raise a toast from the service or the persistence layer. You might remember a toast is a message that appears on the screen briefly. So we don't want to raise a toast. Okay. What if we have an exception that we can't deal with then at the persistence layer? Do we just hide it? That's the worst thing we can do. When we're thinking about the persistence in the service layer, we need to think about exceptions in this way. Number one, they're the exceptions that can be handled. And those are great because we're adding value there. We are taking what could be a bad situation and making it good. For example, online versus offline toggle. I'll show an example of this. Online versus offline toggle. If we try to do something online and we get, say, a network exception, well, we can handle that. We'll just go in offline mode for a moment, save the data locally, and then later on we'll try to resynchronize. We shouldn't shut down the application if we happen to lose network coverage. Instead, we should just cache data locally and synchronize at a later point and let the user keep using. That's an example of an exception that can be handled at the persistence layer and the user doesn't even have to be informed. Now, let's think of another exception that we can't handle. Think about if we are storing images from the camera and we run out of disk space, or I guess really it would just be memory space. There's nothing we can do. The best thing then is to inform the user. But remember, we're going to find this in the persistence layer. So if we're in the persistence layer and we get an exception that we need to tell the user about, what we can do is simply throw that exception. Throwing the exception means give it back to the layer that called us. Okay? And we will keep bubbling up this exception until we hit the point where a toast can be raised. And that way we can still stay independent of the operating system at the persistence layer and at the service layer. We can still raise a toast to the user, but we do it by bubbling up the exception to that UI layer. So let me show you some examples. First of all, in the plant places, the real life plant places, 1 second please. Okay. This is exactly what I was talking about with toggling between online and offline. Okay? So Online plant DAO, fetch by plant search, and it's passing in a plant search object here. Let's click on this. Whoops, I went to the interface, sorry. Oh, whoops. Okay, fetch by plant search. Okay. So this is actually going to go to a URL, and it's going to try to access that URL. It's going to get data back from that URL, and then it's going to populate a collection of plants from data that it found online. Okay? But let's say that we're offline. That's going to happen frequently. Maybe we're in an area that doesn't have cellular coverage. Maybe we're in a different country. If that's the case, then we simply catch an exception that it was unable to connect, and we go to the offline plant DAO instead. Whoops, sorry. We go to the offline plant DAO, and we simply have that do it using a local copy of data. Okay, so this is an example of an exception that can be caught and handled at the location where it occurred without bothering the user. Okay. Now, another exception, as I mentioned, would be something like running out of disk space. In that case, instead of catching the exception and just handling it, we would rethrow the exception all the way up to the user and then raise a toast there. Okay, the reason why I bring this up now is that there are two things we absolutely positively never want to do. Number one, we never want to have a try catch and leave the catch empty. I'll be looking for this on the final project. Make sure you don't do that. The reason is exceptions are very good. Even if it means we have to kill the program for some reason, they contain very valuable information. We should at the very least be logging that information. If you have an empty catch block, you are throwing that information away, and debugging becomes extremely difficult to do because you have no idea what went wrong. Okay? The other thing you don't want to do is catch an exception and return null. This is what people do a lot of times to try to just get out of it. But the problem is, if you catch a legitimate exception and return null, many times this method that's returning a value, that value is going to get assigned to a variable. That variable is then going to have the value null. Later on, somebody might call a method on that variable. If you attempt to call a method on a variable that is currently set to null, you will get a null pointer exception, and that has almost zero information in it. So, when you have a catch block, put something in it. Think about it. Is it a situation you can handle locally? If so, then handle it like we see here. If not, rethrow it. But never leave an empty catch block, and never have a catch block that returns null. Those are two things you should never do. Now, there are generally two types of exceptions in Java, what we call checked and unchecked exceptions. A checked exception means that the Java programming language wants you to consciously think about something that could happen in real life through no fault of your own. For example, running out of disk space, or a file not found exception, or a network exception. These are things that could happen in real life. For checked exceptions, when you invoke a method that might cause this exception to occur, you are forced to surround it with a try-catch. Okay? That's what a checked exception means. If you call a method that's going to access a file, then you have to handle a file not found exception. Let me see if I can find an example here. One second. I don't see one here. One second, please. I'm trying to think. This is the real plant places, and I'm trying to think if I ever actually write to a file. I don't think I do, actually. Oh, you know what? I'm in the service layer. Hang on a second. 1 second, please. Okay, and here we have where I'm trying to save a picture. And if something goes wrong, I'm testing several different conditions here. If something goes wrong, I am throwing an informational exception that says cannot write to media. Media is not in a writable state. So the SD card is maybe locked to be read-only, Well, that's something where I want to tell the user, I want the user to take care of it. Hey, your SD card, it's either full or it's read-only. So in these cases, I'm going to throw an exception. Notice I'm in the persistence layer. I'm in com.plantplaces.dao. I'm in the persistence layer, so I don't want to raise a toast. What I'm going to do instead is I'm going to throw this exception back to an activity and let that activity raise a toast. Okay? So there we have it. So checked exception we are forced to handle. The other type of exception is an unchecked exception. An unchecked exception is something that should be prevented and we're not forced to handle it. It could happen anywhere, but we should write programs so that unchecked exceptions just don't happen. An example of an unchecked exception is a null pointer exception. We shouldn't be calling methods on variables that are set to null. That's a null pointer exception. Another unchecked exception, an array index out of bounds exception. So if you've ever had an array of, say, size 2, and you try to access element 5, that will throw an array index out of bounds exception. It's something you should prevent. Okay? Number format exception. If you take the letter ABC and try to parse it into an int, you'll get a number format exception. These are all unchecked exceptions. Good programming practices should avoid these. You're not forced to do a try-catch around them. Instead, you should just prevent them. Checked exceptions was the first category I talked about. Some examples of that would be file not found exception. I believe there is a SQLite exception for accessing a SQL database. So file not found exception is a common one. I want to say IO exception, but I'm not absolutely certain about that one. There's a network exception that's a checked exception. Anything that could occur external to the program usually that we want to consciously think about how we would handle would be a checked exception. Okay, all of this being said, I'm going to go back now to my iPlant service, and we know we have a couple of methods here. Fetch all genus and fetch all categories. Right now we have this wired up to a stub, and that stub is just giving us some known data in return. Eventually we're going to hook this up to the network. And so there is a good chance that we could have that online-offline problem or one of any other issues. So I'm going to add to this throws exception, which means that whoever calls this method now has to decide what to do if an exception is thrown. Okay, and we save. Now I'm going to have to go back to my plant service stub, and I'm going to have to make these methods match. So throws exception, okay, and throws exception. Okay, and save. Okay, now what's interesting is that my plant search activity is redlining. And if I mouse down, I'll find out why. I mouse over. Okay, we'll try here. A little bit slow today. Unhandled exception type exception. I've just made this a checked exception because I'm calling a method that says it's going to possibly throw an exception. So what I would do here then is I would maybe surround this block with a try-catch, surround these statements. Catch exception E. And then what I might want to do is raise a toast. I definitely don't want to leave this empty, but I might want to raise a toast and say toast.makeText. Okay, let me do that again so I can, okay, context is this. Text will be e.getMessage. If you invoke e.getMessage on an exception, and notice the exception is named E. You'll see that when this context-sensitive help leaves. If you call getMessage, it will tell you what went wrong on that exception. Okay. 1 second. Okay, and then duration, I'll say toast dot length long, and then I'll say dot show. And there we go. So we've bubbled the exception up to the activity level, and we're telling the user how to deal with it. I'm going to Control A and then Control I, which will fix my indents. Okay, when I'm recording on Screencast-O-Matic, there's a little box that appears on my monitor that shows what's getting captured, and that box disappeared. Luckily, it was capturing my screen anyway, but I noticed that my ellipse is a bit off, so I'm going to recenter that now, and we'll continue. Okay, so I have handled the exception, and I'm going to save. Now, this toast.make text, we'll use that just for exceptions that can't be handled at the persistence or the service layer. In truth, we know when we do the actual plant service, if we do get an offline online issue, if we lose network coverage, we're just going to toggle over to an offline cache. So that is something that can be handled locally. So, moral of the story here, we should never have an empty catch block. At the very least, we should log it. We should never return null from a catch. If an exception happens at persistence or service layer, we should try to deal with it there. If we can't, we should rethrow it until we get to an activity. Also, we know there are two categories of exceptions. Checked exceptions are things like file not found, and Java forces us to surround those with try catches or rethrow it and determine what we're going to do. Unchecked exceptions are things like null pointer exceptions, array index out of bounds exceptions, and number format exceptions, exceptions that we should prevent from ever happening. So, one other thing, while I'm here, I will go ahead and say log.error, or log.e rather, okay, and I'll say this.getClass.getName, comma, e.getMessage. Android has built-in logging. And oops, I need to do open and close paren here. Android has built-in logging. We just have to reference this log. As a matter of fact, it might be capital L log. Let's see if it likes that better. Let me Control-Shift-O, organize imports. There we go, we got it. Okay, hopefully, there we go. Android has built-in logging. This is another thing we don't cover a lot in college classes, but is very important. Anytime we have an exception, we want to log it. Now, when we're in college, we make programs and we think that programmers spend their entire life programming. In reality, we spend a lot of time debugging and trying to figure out why things went wrong in the past. One of the most important skills you can have as a programmer is the ability to know how to debug, know how to look at logs, know how to handle exceptions, and do it in the right way. That's honestly what I spend most of my job doing now, is looking at times that point of sales have not operated properly and trying to figure out why they didn't, and then trying to fix it. That's not easy. Many times, silly error, you won't have a lot of information, and it can take an entire week or so just to figure out what happened, if you even can figure it out. So logging is very important. One of my former students I work with today, one of my first students back about 11 years ago, and before he went to UC, he was a copier repairman. And at work, our ice machine broke in the break room. And a few minutes later, I walked in and he had the entire thing taken apart. And I realized then that having a skill like being able to fix a copy machine or being able to disassemble something and figure out why it's not working is definitely a great prerequisite to being a programmer. Because while we have fun building things, we really spend a lot of our time taking things apart, figuring out why they went wrong. So that's exceptions. We're about at the 20-minute mark, which is a bit short, but our next couple of topics are not directly related to exceptions. So I'm going to go ahead and save this one, and then we're going to pick back up with menus and intents. Thank you.